see about the combinational logic, and the logic circuit for digital system may be of two classification, which is combinational logic circuit and sequential logic circuit. So here combinational circuit means it consists of logic gates whose output are at any time that are determined from the present combination of inputs. So here number of inputs determine the number of outputs which we get it in a combinational circuit, and this circuit consists of gates like NAND gate, NOR gate, OR gate, etc. So this combination which has been implemented in a circuit is combinational circuit, and this performs operations such as Boolean functions and along with the arithmetic operations. So next is sequential circuit. So this employs storage of elements in addition to logic gates. Their outputs are the functions of the inputs and the state of the storage element, and the output of the sequential circuit depends not only on the present value of input but also on the past inputs. So sequential is it takes output of the previous one and it takes at the input for the current gate or the circuit. So this is how the sequential circuit works, and the circuit behavior must be specified by time sequence of inputs and internal states. And the combinational circuit consists of input variables, logic gates and output variables. So the logic gates accept signals from the inputs and generate the signals to the output, and this process transforms binary information from given input data to a required output data. So here is the block diagram which explains the combinational circuit here. So as we see here n inputs have been given, and through the combination circuit we get m outputs, that is number of input, and the output will be the same, and the count will be same. So the n input binary variable comes from an external source. The output variable m go to an external destination. So input and output binary signals represent logic 1 and logic 0. So for n output variable, there are 2 per n possible binary input combinations. For each possible input combination there is one possible output value. So a combinational circuit can be specified with a truth table that lists output for each combination of input variables. A combinational circuit can be described by m Boolean functions and one for each output variable. Each output function is expressed in terms of input variable. So here first one is we'll see the steps which we follow in simplifying a Boolean function. So first we use K-map, that is Karnaugh map. So the simplification of the function using Boolean law and theorems becomes complex with increase in the number of variables and terms. So here K-map is proposed by Veitch and slightly improvised by Karnaugh. The map method provides a simple straightforward procedure for minimizing Boolean functions. So map method is also known as Karnaugh map or K-map or Veitch map. Venn diagram regarded as the pictorial representation of the truth table. So here as we see here this role, the K-map can be used for expressions with 2, 3, 4 and 5 variables. So here are the example K-maps for K-map representations for different variables here. So as we see here, 2 variable map will be represented with m0, m1 and m2, m3 square boxes, and the min term values, the values which will be replaced here in the place of m0, m1, m2 are known as min terms. And as we see to the right side, here is the K-map diagram for pictorial representation which has been derived from truth table for 2 variable K-map. So here x and y are the variables here, and here the K-map for x and y have been plotted here. So as we see x values we use logic 0 and logic 1, and here for y we use logic 0 and logic 1. So here when 0 and y0 meets, here we will take it as x dash and y dash. That is, we will take the complementary of the given variable. That is, x variable is considered as x dash and y variable will be considered as y dash. So whenever the 0 comes, we will be taking the variable's complement value. So here for in the first square box we will have the x dash and y dash value, and in the next square box we will have x dash and y, since x value is 0 and y value is 1 here. And coming to the second row, we will have x value and y dash value. Since the x value is 1 here and y value is 0, we are taking a complement of the variable y. And next square box will have x value 1 and y value 1. So here since both the values of the variables are 1 here, we will be denoting it by xy. So here we will have the 3 variable k-mapping for 3 variable usage. So as we know here, we are will be denoting the min terms from 0 to 7 here, and the x value, x, y, z or the 3 variables we have considered here. So these are all the example for k-map here. So thank you.